Now the next question is, in how many ways can 88 be written as a product of two factors? So it's product of two factors, okay? So for that we have a shortcut. I'll also explain you how to do it. But the shortcut here is number of ways a number can be written as a product of two factors is given by. Now factors, there's a difference between product of two factors and in this question here we have been given product of two numbers. There's a huge difference between product of two factors and product of two numbers. Factors can only be positive, okay? There are no negative factors. But numbers can be positive as well as they can be negative. So if it is asking in how many ways 88 can be written as a product of two factors, you first have to find out the total number of factors of 88. So if you write 88, 88 can be written as 2 cube into 11 to the power 1. How many total factors does 88 have? Increase each power by 1. So 8 factors. There are 8 factors of 88, isn't it? Now, we just have to find out in how many ways 88 can be written as a product of two factors. So when I talk about factors, the number of total factors can be even or it can be odd as well. If it is even, the total number of ways will be p by 2. If the total number of factors is odd, the number of ways will be p plus 1 by 2. Okay, so here we have even number of factors. So answer will be 8 by 2, that is equal to 4. What are those uh, four factor pairs for this particular question? That will be 1 and 88. Then we have 244. Then we have 422. And then we finally have 8 comma 11. That's it. Okay, there are no other pairs. Understood? Many of you might be thinking we could have also written 88 into 1, but that is basically the same as this, okay? Because there are no variables mentioned over here in this particular question, okay? Now, let us come to this question in which in how many ways 88 can be written as a product of two numbers. So again, here we'll have to calculate the total number of factor pairs. So there are 8 factor pairs in total, okay? Right? But what do we have to do here? We also have to take negative numbers into consideration. When I counted total factor pairs, it just gave me positive factor pairs. But since I have to count negative as well, okay, the negative ones as well, there'll be equally, I mean, same number of negative factor pairs as well, like -1 and -88. They also have a product of 88, isn't it? So whatever factor pairs you get here for this particular question, okay? So I am writing 88 as a product of two numbers, isn't it? So one number will be x, another will be y. It has to be 88. And product of two numbers, they can be negative as well, positive as well. So 188, then we have 244, then we have 422, then we have 811, right? Then we have 118, then we have 22 4, then we have 44 2, and then we finally have 88 comma 1 and their negative parts as well, -1 -88 -2 -44 till -88 -1. So there'll be total, I mean this will be double directly, okay? The answer will be 16. Let us try to solve this question. What is the sum of all 4-digit numbers that can be formed using digits 1 2 3 4 5 if a digit can be used at most once? At most one means there's no repetition allowed, okay? Now, in how many ways can you select 4 digits out of these 5 digits? 5C4, out of 5 you're selecting 4, and then those 4 will be arranged in 4 factorial ways. So how much is this? 5. 5C4 is 5 into 4 factorial, that is 120. So there are total 120 numbers of 4 digits that will be formed. Okay. Now one concept is very important over here, that is each digit will occur at each position equal number of times. So we have 4-digit numbers, we'll have 4 positions, isn't it? So if I just talk about the number 5, okay? If I talk about the digit 5, just 5, then there'll be 24 numbers, okay? There'll be 24 numbers in which 5 will occur at the ones, tens, hundred, thousand place. So I'm talking about thousand place, thousands place, okay? Why? Because if you fix 5 over here, you remain with, I mean, see, one number has been fixed over here, right? You still have 4 numbers to pick up from. So 4 into 3 into 2, because there's no repetition allowed. 4 into 3 into 2 is 24. So there are 24 combinations possible over here with 5 being the first digit. So there'll be 24 numbers in which 5 will be the first digit. There'll be again 24 numbers there'll again be 24 numbers in which 4 will be the first digit, that means 1000 digit. Okay. Similarly, there'll be 24 numbers in which 3 will be the first digit, 2 will be the first digit, 1 will be the first digit. Now just try to understand one thing over here. You are trying to find out the sum of all such 4-digit numbers. So there are 24 numbers in which first digit will be 5, and as you know, 5 is the first digit. That means it's not just 5, it's actually 5000. Yes or no? It's a 4-digit number, so it will give you 5000. So 24 into 5 into 1000, right? This will be the sum of these fives which are occupying the first position when you take it as a number, isn't it? Now, there are 24 numbers in which 4 is at the 1000 place. That means all these 24 numbers will have 4000, 4000, 4000. Yes or no? So 24 numbers, all of them, when 4 is at 1000 place, this will be the sum formed. Similarly, 24 numbers, 3 at 1000 place, this is the sum. 24, 2 at the 1000 place, this is the sum. 24, 1 at the 1000 place, this is the sum. So for 1000 place, we have got the sum. Now, obviously, their 100 place will also be added. Okay. So if you talk about a 4-digit number and suppose you fix a number 5 over here. So this is one. I mean, one possibility over here. You still have 4 numbers. So 4 into 3 into 2. That means if you fix 5 as the ones, tens, hundredth digit. Okay, let me write it, 100 digit. Then what is going to happen? There'll be 24 numbers in which 5 will be at the 100 place. There'll be 24 numbers having 4 at the 100 place, 3 at the 100 place, 2 at the 100 place, 1 at the 100 place. So what will be their sum? If there are 24 numbers having 5 at 100 place, okay, this will be their sum. 24 numbers having 4 at the 100 place, and similarly 24 numbers having 1 at the 100 place. In the same way, if you talk about a 4-digit number and suppose you fix, say, number 5 at the 10th place. So one number has been fixed. How many numbers are possible? 4 into 3 into 2. 4 into 3 into 2 is 24. There'll be 24 numbers possible in which 5 will be at the 10th place. So what will be their sum? 24 numbers all giving a 5, and due to place, I mean, it is at the tens place. So this will be the total value in the sum. And similarly, 24 into 4 into 10. And similarly, 24 into 1 into 10. And finally, we'll have one digit numbers. There'll be 24 numbers in which 5 will be at the unit place, 4 will be at the unit place, and so on, so on, so on till 1 at the unit place. Why am I explaining this? See, there's a shortcut to this problem, but it only makes sense if you remember the functioning. Okay, so this is the function. If you now find out the sum, what do you see in each and every number? 24 into 5 is there, which is common in all the numbers. So let me just erase a bit over here and let me make space for rest of the calculation. So can I just take, say, 24 common out of all the numbers? Each and every number here, 24, 24, 24 is there in all the numbers. Okay. Then can I take 1000 common? Yes, 1000 is there common in 24 numbers. Okay. Then 100 is common in 24 numbers, so 100 can be taken common. 10 is common in all 24 numbers here, so 10 can be taken common. And then uh, what is this? 1, right? I mean, if you check 24, 24 is common in all these 24 numbers. So that is basically 24 into 1. So plus 1, isn't it? What else do we have in this? There were 24 numbers giving a value of 1000 due to the place value 1000, and all having a weight of 5 plus all having weight of 4, isn't it? Then 3, then 2, then 1. So what happens here? If you ultimately find out the sum, it is 24 into 1, 1, 1, 1 into how much? 5, 4, 3, 2, 1. 5, 4, 9, 9, 3, 12, 12 to 41, 15. Whatever is the value of this, that will be the answer. Okay? So what is the shortcut here? First of all, you have to check how many such numbers will be formed. So that is 5c4 into 4 factorial. This is the total number of numbers formed, right? And then what you have to do is write equal number of ones. You need 4-digit numbers, so write 4 ones and then the sum of all the numbers. So sum of all the numbers which are given to you 5, 4, 3, 2, 1. It basically gives you the same. Okay. Now the next question is if 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square up to infinity is equal to pi square by 6. So this is given. Okay. Find out the value of this up to infinity. So here we have 1 square, 2 square, 3 square till infinity. Here we need 1 square, 3 square, 5 square. So odd terms are there, square of odd terms in the denominator. Okay, how to do it? We have to separate the odd terms. So let's just write down 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus 1 upon 4 square, so on, so on, so on, up to infinity as pi square by 6. I just want 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square and so on here. So that will be pi square by 6 minus all these even terms 1 upon 1 square, 1 upon 4 square, 1 upon 6 square will be sent here. So 1 upon 2 square plus 1 upon 4 square plus 1 upon 6 squares and so on, so on, so on will be sent here. How to do this now? Pi square by 6 minus. Now this is known to me, okay? Can I make it 1 upon 1 square, 1 upon 2 square, 1 upon 3 square? If I take something common, see, we can see that all the denominators here are even numbers, square of even numbers. So can I take 1 by 4 common out of these? Yes, I'll get 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus 1 upon 4 square and so on, so on, so on till infinity. So I just took 1 upon 2 square common, that is 1 by 4. So what do I get now? Pi square by 6, okay, minus 1 by 4. This sum inside ultimately is pi square by 6 only, which was given to me. So pi square by 6. So what is this? Take pi square common, we get 1 by 6 minus 1 by 24. What do you get? You get 18 by 24, isn't it? Sorry, 1 by 6, 1 by 24, 3 by 24, 1 by 8. So pi square by 8. This is what you get at the final answer. So option A is your answer for this particular question. Okay, it has come in IPMAT earlier. Now let's go to these special questions. Okay, mod x plus mod y equal to n has 4n integral solutions. Integral means integer solutions. Okay, mod x plus mod y plus mod z equal to n has 4n square plus 2 integral solutions, where n is a natural number. If n is equal to 0, n is the number on the right hand side. Okay, if it is 0, then only there'll be only one solution for n. Okay, so how to do this? We have this question: how many integral solutions are possible for mod x plus mod y less than equal to 4? Integer solutions, that means mod x plus mod y will be either equal to 4 or it will be equal to 3 or 2 or 1, okay, or 0. Not below that, because mod x, mod y both are positive numbers. They cannot have a negative sum in total. So this will have 4n solutions. What is n? N is 4, so 4 into 4 solutions. 4 into 3 solutions, 4 into 2 solutions, 4 into 1 solution. Now here, it won't be 4 into 0. I just told you that if n equal to 0, there's only one solution, and that is 0 plus 0 equal to 0, right? So there'll be one solution here. So 4 for 16 plus 12 plus 8 plus 4 plus 1. That is 28 plus 8, 36. 36 and 5, 41 integral solutions will be there. I hope this is clear. Okay. So this is for two modulus only. Okay, when two modulus are being added, two modulus equations being added equal to n, it has four integral solutions. While three modulus being added equal to n, it will have 4n square plus 2 integral solution, and is the number on the right hand side. N should be a natural number. Okay, this is natural number for natural numbers only. Integral obviously is for natural numbers only. Okay, I mean integral means integer solutions. Obviously you cannot have fractional values here. N equal to 0, only one solution for n. Okay. Now let's come to this non-negative integral solutions of mod x, mod y, mod z, mod w equal to 20. Non-negative. Non-negative means 0 is allowed. Okay. 1 is allowed. 2 is allowed. Okay. So obviously we want some of these numbers equals to 20. So these numbers can be 0 or more. These are all moduluses. They can be 0 or more. 0 or more means non-negative integral solutions. So what is the total number of non-negative integral solutions for something like this? If sum of multiple terms r terms x plus y plus z is equal to plus up till some r terms is equal to n, then the total number of integral solutions is n plus r minus 1 c r minus 1, okay, where r is the Number of terms. R is the number of terms. So this is exactly the same, yes or no? Because these can be zero or more. These all moduluses can be zero or more. And it is same as finding out the integral solutions, non-negative integral solutions for such an equation, which is n plus r minus 1 c r minus 1. So n is the number on the right hand side plus r. R is four terms. 1, 2, 3, 4 terms here. N plus r minus 1 c r minus 1. Okay, that is 23c3. That's the answer. Okay. So sometimes they'll give you modulus just to confuse you. You just have to think this way. Okay. Number of integral solutions of xy equal to 144. Integral solutions, that means product of two numbers is 144. Both the numbers will either be positive because positive into positive is 144, or both the numbers will be negative. So obviously, when we talk about integral solutions, 144 is what? 12 square, and 12 is actually 2 square into 3 ka square, and that is basically 2 to the power 4 into 3 square. What is the total number of factors of this? Total number of factors of this is 4 plus 1 5, 2 plus 1 3, that means 15. So there'll be 15 positive factor pairs, but since we have to take negative ones into account as well, like minus 1 into minus 144, minus 12 into minus 12, so 15 more pairs will be there. Total 30 such integral pairs will be there. So you also have to count negative ones in integral solutions. If it says positive integral solutions, then you will only count the positive factor pairs. I hope this is clear. Now let's come to this. The inequality, this x square minus 2x plus 1 less than equal to 0. So this is basically x minus 1 ka square less than equal to 0. This is a square, obviously. So this is a square. It can have minimum value 0. Okay. So my inequality says that the value of this should be less than 0 or equal to 0. It can never be less than 0. It can never be less than 0. So it can only be equal to 0. So x minus 1 square can only be equal to 0. Okay. 0 or more. But we want less than 0. I mean less than equal to 0. So we can go up till 0 only. So for how many values of x does it become 0? Only for one solution, one value of x, that is x equal to 1. So even though you guys might be thinking that this is a quadratic equation, two solutions will be there, 1, 1. But number of unique solutions is 1 only. Okay. I hope this is clear. Next is if x1, x2, x3, so on, x5 are the distinct roots of this equation, 3x ki power 5 plus 8x ki power 4 plus 3x cube plus x square minus 4x plus 1 equal to 0. It wants us to calculate the numerical value of this 1 plus x1 into 1 plus x2 into 1 plus x3 up till 1 plus x5. So just take a smaller product. Okay, let's suppose I ask you to tell me the value of 1 plus a, 1 plus b, 1 plus c. Okay, so what do I get? A plus b plus c plus ab plus bc plus ca plus abc. These are the terms that I'll get. ABC means sum of these terms ABC taken one at once, right? This is the sum of two values, two variables taken together. This is three variables, right? So if I solve this part, I'll get 1 plus sum of all variables x1, x2, x3 till x5 taken 1 at once, right? Then taken 2 at once, x1, x2, x2, x3 up till x4, x5, right? This is what I'll get, plus taken 3 at once. So x1, x2, x3 plus x2, x3, x4 and so on, so on, so on. X3, X4, X5, right? And after that, taken 4 at once. So X1, X2, X3, X4, and similarly taken 4 at once. And this will be final X1, X2, X3, X4, X5, and all of them will be multiplied. So this is sum of the, see, what are these? These are the roots. So this is sum of roots taken 1 at a time, sum of roots taken 2 at a time, sum of roots taken 3 at a time, sum of roots taken 4 at a time, sum of roots taken 5 at a time. In fact, this is not sum of roots taken 5 at a time. This is the product of all 5 roots, isn't it? So when you have a quadratic equation like this, ax square plus bx plus c equal to 0. What is the sum of alpha plus beta? If alpha plus beta are the roots, this is the sum of roots taken one at a time. It is always equal to minus b upon a. And if it is product of roots, then it is always c upon a. C upon a is constant term upon a, isn't it? Now, suppose if I do it for a cubic equation like this, ax cube plus bx square plus cx plus d equal to 0. Then if I write down the sum of roots, just sum of roots taken one at a time. Okay, sum of roots taken one at a time. That means there are three roots of this. This is a cubic equation. So roots will be alpha plus beta plus gamma. That will always be equal to minus b upon a. Remember this. Okay, this is very important. If you take sum of roots taken two at a time, that means we are talking about alpha beta plus beta gamma plus alpha gamma, and that will always be equal to c upon a. Okay, next when you take all three roots at a time, you will get alpha beta gamma. That will always be equal to minus d upon a. What do you see here? You start with sum of roots taken one at a time, you will get minus b upon a. Next sum of roots taken two at a time will be c upon a, but positive. Alpha beta gamma, three taken three at once, it will be minus but d upon a. And next, if there would have been four roots alpha beta gamma delta, then it would be something else but in positive, isn't it? So what we'll do here, this is 1 plus sum of roots taken one at a time. It will be minus b upon a. Sum of roots taken two at a time. Okay, that will be c upon a. Then sum of roots taken three at a time. It will be minus d upon a. This is sum of roots taken four at a time. So plus e upon a. And finally, we have all product of all, that will be minus f upon a. Always remember this. Okay, so 1, then minus b upon a. Next we'll have positive sign, so c upon a. Next we'll have negative sign, d upon a. Next we'll have positive sign, e upon a. Next we'll have negative sign, f upon a. So can you relate this with ax to the power 5 plus bx ki power 4 plus cx cube plus dx square plus ex plus f equal to 0. Now you just have to find out the sum, minus b upon a. So b is 8, a is 3. So 1 minus 8 by 3. Then c upon a, that means 3 by 3. Then minus d by a. So a, b, c, d. Minus d by a, minus 1 by 3. Then e by a. E is minus 4. So minus 4. Okay, plus e by a. Na? So minus 4 by 3. And then finally minus f upon a. That means this constant term minus 1 upon 3. You can simply find out the sum and you'll be getting your answer. I hope this is clear. This is very important, okay? Learning the sum of roots taken one at a time, two at a time, three at a time, four at a time, five at a time, whatever. Okay? Now let's talk about this. If fx equal to x square minus 63x plus k equal to 0, for what value of k will the roots of fx be prime numbers? We are talking about roots. It's a quadratic equation. If alpha beta are the roots, the sum will be minus b upon a. So 63. So there are two roots and we want their sum to be odd, right? And both of them, alpha beta, have to be prime numbers. So 2 is the only even prime, and you know that all other primes are odd. So can alpha beta both be odd? No. If they are both odd, odd plus odd will be even number. So that's not possible. That is 100% a chance key. There's 100% chance that odd plus even will give us odd sum. So when can a prime number be even? Only when 100% one of them is 2, another is 61, which is odd. So odd plus even, odd sum. We want 100% these can be the roots, right? We want their product, obviously. Why? Because we want the value of k. K is nothing but the product of roots. No, k is k upon 1. So product of roots, k is actually the product of roots. So we've just got the roots 2 and 61. So 2 into 61 is 122. That's the only possible case. 122 will be the answer. I hope this is clear. So this is related to the concept of prime numbers and quadratic equations. Let's talk about this. Find the sum of the following infinite series. So you see here that 3, 9, 27, 81. Okay, let's assume this is S. If this is S, I know that the common ratio here is 1 by 3. So I'll multiply my S by 1 by 3 and I'll get 1 by 9 plus 4 by 27 plus 7 by 81 plus 10 by 243 plus 13 by 729 and so on, so on, so on. From S, we'll subtract S minus 3. So S minus S by 3 is 2S by 3. Okay. And that is equal to 1 by 3. From 4 by 9, I subtract 1 by 9. So let me just write 1 by 3 here. Plus 4 by 9 minus 1 by 9 is 3 by 9. Yes or no? Then 7 by 9, 7 by 27 minus 4 by 27 is 3 by 27. Then 10 by 81 minus 7 by 81 is 3 by 81, isn't it? Then 10 by 81 minus 7 by 81 is 3 by 81, and obviously this 3 by something will keep going on till infinity. So 2s by 3, that is equal to, uh, let's keep this 1 by 3 separately, plus in all these fractions 3 is common, so let me take it common, and we'll have 1 by 9 plus 1 by 27 plus 1 by 81 and so on, so on, so on common. So we finally have 2s by 3, that is equal to 1 by 3 plus 3. This is an infinite decreasing GP, right? What is the sum of a decreasing GP? A upon 1 minus R. A is first term 1 by 9 minus 1 upon 1 A upon 1 minus R. R is 1 by 3 is the common ratio here of this infinite GP. So what do we get? We get 2s by 3, that is equal to 1 by 3 plus 1 by 9 into 2 by 3 will be this. So 1 by 6. So 3 into 1 by 6. So this gives us 1 by 2. 1 by 3 plus 1 by 2. So 2s by 3 is 1 by 3 plus 1 by 2 is 5 by 6. Right? 3 cancels this. We get 2. So s will basically be 5 by 4. 5 by 4. What was s? S is the sum of the series. That is our answer, 5 by 4. So these are easy to do, okay? What about this? How many integral values of x less than 100 are there such that root of x plus inside root of x, then root of x, this continues forever, is equal to y? So this is x, root of x plus root of x. So this is infinitely containing root inside the root. This entire is equal to y. So can I just say that this can also be taken equal to y? Because these are infinite roots, x. It can be called y. So I can say x plus y. So you have to transform it this way in the exam, okay? These are multiple roots inside each other. Just leave one x here and then call rest of the given root inside root equals to the given expression only, okay? I hope this makes sense. Square both the sides. If you square both the sides, you get x plus y equal to y square. So x is basically y square minus 5. X is basically y times y minus 1. Now x has to be a number which is a product of y and y minus 1. That means two consecutive numbers, and the value of x should be less than 100. So uh, x x can have minimum value 0 because x is a term inside the root, isn't it? It will always be 0 or more. So x can have value 0, okay? For that, y has to be 0, isn't it? Y will be 0, isn't it? Now, x is basically the product of two consecutive numbers over here. So I've taken 0 into 1. Next will be 1 into 2, obviously. So next value of these y into y minus 1. Let me write down y into y minus 1. These are the two terms we are multiplying. So y0, this is 1. Next will be 1 into 2, 2 into 3. We just have to keep the product less than 100, okay? Because this is the product, y into y minus 1. It is the value of x, and x has to be less than 100. So 2 into 3 is 6, 3 into 4 is 12, 4 into 5 is 20, 5 into 6 is 30, 6 into 7 is 42, 7 into 8 is 56, 8 into 9 is 72, 9 into 10 is 90. 10, sorry, if you put it as, I mean, if you put y equals to 11, it becomes 11 into 10, right? So y maximum can be put 10. So 0 into 1, then 2, then 3. So from 1, we went till 10. So there are 10 pairs. So there will be 10 different values possible for x, because this is nothing but the product x only. I hope this get ends the answer for this particular question. 209. Find the radius of the circle inscribed in a rhombus with diagonals 12 and 16. So you know what a rhombus is, right? Rhombus is a quadrilateral in which all four sides are equal, but it's not necessary that they are at 90 degree the sides, okay? Then circle inscribed in a rhombus. It will look something like this. Yes or no? Okay. Diagonals are 12 and 16. This is the shorter diagonal. Obviously, this will be 12 and this will be 16. You know that the diagonals of a rhombus, they are perpendicular bisectors of each other. So this is shorter diagonal 12. This half will be 6. This will be 6. This is a longer diagonal 16. This will be 8. So this will be 8. Now these are at 90 degrees. 6, 8, 10. This will become a Pythagorean triplet. Okay. What do we need? We need the radius of the circle. So from here, obviously, this is a tangent. The angle will be 90 degree. So if you talk about the area of this triangle, it can be taken as half base 6 into height 8, 6 into 8. And that is also equal to what? Half when you take 10 as the base and r as the height. So 10 into r. Half half cancels, 48, 48 by 10, r will be 4.8. So that will be my answer for this particular question. I hope this is clear. Now let's talk about this. A granite stone has been purchased to build the kitchen platform and dining area of Mr. Kumar's bungalow. The cost of the stones varies directly with the square of its weight. The stone broke into four parts whose weights are in ratio 3579. If the granite stone had broken into four equal parts of weight, then it would have led to a loss of this much. What is the actual cost of the original granite stone unbroken? So these are the pieces, okay? Let's say their weights are this 3x, 5x, 7x, and 9x. So it says that cost of the stone varies directly with the square of its weight. So weight square. Okay, these are the weights. Okay, of the all the pieces. So cost can be written as you have to remove the constant of proportionality, write it as k. And if I take the weight of this piece 3x, so its weight will be 3x square. Okay, so it will be 9k x square. Weight of this piece of 5x will be k into 5x square. That means 25k x square. Weight of 7x piece will be 7x square into k. So 49k x square. And finally 9x piece will have weight k into 9x ka whole square. That means 81k x square. Okay. This is the cost of the granite once it is broken into these pieces. So 925 is 34, 34 and 49 is 83, 83, 81 is 164k x square. This is the cost. Total cost when it is broken like this. But what is the cost when it is broken into four equal pieces? So total weight of the granite is 3579, 9, 7, 16, 16, 5, 21, 21, 3, 24. 24x is the total weight of the granite. Okay. If it breaks into equal pieces, so it will break like this 6x, 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 and 6x. So all four pieces will have same weight. So 4 times k into obviously 6x ka square. This will be the total cost, right? Because cost is directly proportional to weight ka square. So all four pieces having same weight k into 6x ka square, it will become 144k x square. So this is the cost when this was these are the broken pieces. If there are equal broken pieces, then the cost would have been 144 kx square. Now, what does it say? If it had broken into four equal parts of the weight, then it would have led to a loss of this much. What is the actual cost of the original granite stone unbroken? So cost of the original unbroken granite stone will be cost will be equal to k times 24x ka square. So k times 24x square is 576 x square. We need to find out the values of these. I know that there's a loss of this much. That means what is the difference between this price when it was broken like this and this price when it was equally broken into pieces? The difference here is 20k x square. So 20k x square is actually the loss equal to 12240. So 0 cancels 0, 2 cancels this, 612. So can I say that kx square is actually equal to 612? Can you simply put the value of kx square here? K into x square can be put at 612. So total cost will be 576 into 612. So 6 into 2, unit digit will be 2. Obviously, this is the answer, okay? You can simply verify it even without calculating, or else you have an on-screen calculator in IPMAT, you can use that. Okay, this is also a very good question. Now let's come to 211. The greatest among 2 ki power 1 by 2, 3 ki power 1 by 3, 4 ki power 1 by 4 is. Always remember all of these functions are in the form x to the power 1 by 6, x, isn't it? To the power 1 by 2, 3 to the power 1 by 3. Always remember this kind of a function takes its maximum value at x equal to e. What is e? Is the exponent, okay? Exponent, exponential function, okay? And it has an approx value of 2.71. So whichever of these is close to this e, because at e it is going to attain its maximum value. So whichever of these functions is the closest to 2.71, that will be the answer. So is 2 closer to 2.71? No. I mean that 2.71 to the power 1 upon 2.71. This is the maximum value of x to the power 1 by x. So which one of these is the closest to 2.71, or which one is the closest to this? Obviously, 3 is the closest because the difference between 2 and 2.71 is 0.71 is the distance between 2 and 2.71. Between 2.71 and 3, 0.29 is the distance. Between 2.71 and 4, 1.29 is the distance. So this is the closest to x, I mean 2.71. So this will be the greatest. So this is a shortcut. I mean, this is a rare question that can be asked, but still, x की power 1 by x functions might be asked. Okay, so always remember x की power 1 by x functions will always take their maximum value at x equal to e. So whichever of these is closer to 2.71, it'll be the maximum. Many of you might be thinking 2 is closer to 2.71. No, 3 is closer to 2.71 because the difference between 2.71 and 3 is just 0.29, while the difference between 2.71 and 2 is 0.71. So this is the answer. 3 की power 1 by 3 will be the greatest among all of these. Okay. If you talk about this question, three numbers A, B, C add up to 0 and the arithmetic mean of A, B, B, C, C is minus 5. Find the arithmetic mean of A square, B square, C square. So A, B, C are here, A, B, B, C, C are here, A square, B square, C square are here. This can be related to the formula A plus B plus C ka whole square, which is A square plus B square plus C square plus 2 times AB plus BC plus CA. Because these are the terms that occur in the formula of this. A plus B plus C is given equal to 0. So 0 square will be 0. A square, B square, C square. Okay. That will be equal to what? 2 times ABBCCA. ABBCCA. The arithmetic mean of ABBCCA is 5. So arithmetic means their sum. AB plus BC plus CA by 3 is equal to minus 5. So ABBCCA will be equal to 3 into minus 5. That means minus 15. ABBCCA will be minus 15. So plus 2 times minus 15. So this is minus 30. It goes there. We get A square, B square, C square equal to 30. We want the arithmetic mean. So it will be, there are three values divided by 3. That will be equal to 10. 10 is my answer for this particular question. I hope it is clear. Okay. So this is also a good question, but an easy one. Okay. Now we have a question based upon a theorem, which is called cross-ladder theorem. Two lighthouses located at points A and B on the earth are 60 feet and 40 feet tall respectively. Each lighthouse is perfectly vertical and the land connecting A and B is perfectly flat. The topmost point of the lighthouses at A is A dash and one of the lighthouses at B is B dash. Draw the line segments A dash B and B dash A and let them intersect at a point C dash. Drop a perpendicular from C dash to touch the earth at point C. What is the length of CC dash in feet? So there are two towers like this. Okay, one is of 60 feet, one is of 40 feet. This is tower AA dash, this is tower BB dash. Okay, and then we have to connect A dash B and B dash A. Now they are crossing. Okay, they are crossing here. They are intersecting at point C dash. From C dash we have to drop a perpendicular and call it C. So this is also perpendicular, perfectly vertical, perfectly vertical. This is a perfect case of cross ladder theorem. What is that? Take this as a ladder. Okay, A dash B is a ladder. This is how you put a ladder at your home, right? This is the wall. A dash is the wall, you put a ladder to it, and there's another wall, BB dash, you put a ladder to another wall like this, isn't it? So there are two ladders crossing here. It is called cross ladder theorem. In cross ladder theorem, if from the intersection point you want this height, okay, this height. So let me say that this height is A, this height is B, and this height is say H. Then always remember, according to cross ladder theorem, 1 upon H will always be equal to 1 by A plus 1 by B. But it only happens when this, and this. I mean, all the three walls and this height are all parallel. Okay. It can also work in this case. Okay. Suppose this is how you connect the tops and bottoms. So this should be parallel height. Okay, this should be parallel. So 1 upon this will be equal to sum of 1 upon this and 1 upon this. So how can I find out 1 upon h here? It will be the sum of 1 by 60 and 1 by 40. So 1 by h will be what? 100 upon 2400, or we can say that h will be 24. 24 will be the answer to this question. This is a classic case based upon cross ladder theorem. So if a setup like this is formed in your diagram, you can directly apply the cross ladder theorem. Now let us come to this question. An airline has certain free luggage allowance and charges for excess luggage at a fixed rate per kg. Two passengers, Raja and Praja, have 80 kgs of luggage between them and are charged rupees 1800 and 5400 respectively for excess luggage. Had the entire luggage belonged to one of them, the excess luggage charge would have been rupees 10,800. What is the weight of Praja's luggage? So obviously this is what happens at airport, right? You carry some luggage. Some of it is free, but if you carry, beyond 25 kg or 20 kg, they are charge you some excess fee, right? So this is what we have to deal with over here. Let's try to do this question, okay? So here we see that uh, there's some free luggage allowance, okay? Let's say that F, uh, for F kg of weight, you're not charged anything, okay? But two passengers, Raja and Praja, have 80 kg of luggage between them, and they are charged rupees 1800 and 5400 respectively for excess luggage. Okay. So they have 80 kg in total, but in this some free luggage allowance is also there, and then there'll be some excess luggage for which they are charged this much amount. Okay. So how to do this? Let's say that f kg is the total weight which is allowed to be carried for free. Okay. Let's say that for excess we have say r rupees per kg as the excess fee. Okay. Let me say that Raja is carrying say x kg of this luggage. So definitely another person, Praja, will be carrying 80 minus x kg of this luggage, because 80 kg they are having total luggage of 80 kg. If I talk about the rupees, the money that Raja pays, that will be equal to the rate, and then Raja is carrying total x kg, but out of those x kg, some will be free. So he is being charged 1800. And similarly, if you talk about the money that Praja pays, that is again R for what? Obviously, it will be it. He has the total weight 80 minus x, but out of this 80 minus x, there will be some free luggage. So that is equal to 5400. So we have two equations in place, yes or no. But they are saying one more. There's one more condition over here. The excess, if okay, yes, had the entire luggage belong to one of them, that means only one person is carrying the entire luggage. The excess luggage charge would have been 10,800. So again, if R is the rate and one person is carrying entire 80 kg, so out of this 80, some will be fixed. I mean, some will be free charge, right? Free luggage allowed. So F kgs will be free, 80 minus will be charged at R. So they are going to pay 10,800. These are the three equations formed. Okay, using these three equations, we have to find out the value of what is the weight of Praja's luggage. So if we find out X, we'll get 80 minus X, which is Praja's luggage. Okay. Now, if you divide these two equations, what will you get? You will cancel R and you will get x minus f upon 80 minus x minus f, that is equal to 1800 by 5400 is 1 by 3. Okay. And if you divide these two equations, R cancels, 5400 by 10,800 is basically half, 1 by 2. Yes or no? So I'll get 80 minus x minus f upon 80 minus f, that is equal to half. Using this, I'll get an equation in x and f. Using this, I'll get an equation in x and f. Now, these two equations, you have to solve and find out the value of x comma f. You can do that, I know. And once you get x, you just have to push it here, okay? And you'll get the value of 80 minus x, which is Praja's luggage. Weight of Praja's luggage, 80 minus x kg. I hope you can do this. Try it by yourself, okay? What about this? How many positive integers less than 60 have their reciprocals as a terminating decimal? So we're talking about positive integers less than 60. So those are 1 to 60. Their reciprocals, that means 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, till 1 by 60. How many of them have these as a terminating decimal? When do fractions terminate? When either in the denominator you have 2 to the power something, or you have in the denominator 5 to the power something, or in the denominator you have 2 to the power something into 5 to the power something. Except this, no fractions will have a terminating decimal expansion. Like 1 by 3 never terminates, 1 by 6 never terminates, 1 by 7 never terminates, 1 by 9 never terminates. Only those fractions terminate in which in the denominator we have some power of 2 or 5, purely some power of 2 or 5. So 1 by 2 terminates, 1 by 4 terminates, 1 by 5 terminates, 1 by 8 terminates, because 1 by 8 is 2 cube, right? So that means 1 upon 2 to the power something. How many such fractions are there? 1 upon 1, 1 upon 2 की power 1, 1 upon 2 की power 2, 1 upon 2 की power 3, 1 upon 2 की power 4, 1 upon 2 की power 5, not 1 upon 2 की power 6, because 2 की power 6 is 64. If I talk about power of 5, so 1 upon 5 की power 0 has been taken, 1 upon 5 की power 1, 1 upon 5 square, 1 upon 5 cube will not be taken because that is 1 upon 125. Okay. And what about combination of 1 upon 10, something like this? So 1 upon 10, 1 upon 20, that means multiple of 10, right? 1 by 30, 1 by 40, 1 by 50, less than 60. So we'll not go till 60. Okay. We have to stay less than that. Now, what do we see here in this 1 by 10, 1 by 20? I have counted 1 by 30 as well, that will be removed because 1 by 30 has a 3 in the denominator, while all others 50 is purely made up of 2 and 5, 40 is purely made up of 2 and 5, 20 is made up of 2 and 5, 10 is made up of 2 and 5. So 1, 2, 3, 4. 4 values here, 1, 2, 3, 4, 5, 6. 6 values here and then 2 values here. So 6 plus 4 plus 2, that means 12 values in total. So there are 12 positive integers whose reciprocal, if you find out, it will give you a terminating decimal. Okay. Let's talk about this. Himgiri, a juice company, has two bottles of juice. The first contains 50% water and the rest is fruit pulp. The second contains 25% water and rest is fruit pulp. How much juice should be mixed from each of the containers so as to get 16 liters of juice such that the ratio of water to fruit pulp is 6:10? So we finally see that there are two containers like this. Okay, we have not been told there. I would say their total volume. Say this was X in total, this was Y in total. Inside this X, what do you have? The first contains 50% water, that means 0.5, that means 50% of X will be water, while 0.5 X will be pulp, right? Inside this second container, 25% is water, so 25% means 0.25 of Y. Okay, that is water, while the rest is pulp. So 0.75y will be pulp. Okay. How much juice should be mixed from each of the containers so as to get 16 liters of juice? We are trying to get what? In total, we are trying to get 16 liters of juice over here. Okay. Such that ratio of water to fruit pulp is 6:10. 6:10, they are also adding up to 16. That means definitely there is water to pulp. This is water to pulp. So water should be 6 in total and pulp should be 10 in total. 6, 10 will be 16. So total water that we will be getting after adding these two, total water will be 0.5x plus 0.25y. That should be equal to 6. Total pulp 0.5x plus 0.75. 0.5x plus 0.75y. That should be equal to 10. If I solve these two equations, I'll be getting x and y. And through that, I'll easily be able to get how much juice should be mixed from each of the containers. So we'll get the value of x and y. That is what I need. How to solve this? Uh, See, can you multiply to get rid of these decimals? Can you multiply first entire equation by 4? You will get 2x plus y, that is equal to 24. The second equation, if you multiply by 4 both the sides, you will get 2x plus 3y equal to 40. Now just deduct these. Okay, 2y will be equal to 16, y will be 8. If y is 8, obviously x is also 8. So that means you needed 8 liters of this, 8 liters of this, 8, 8. That will be your answer. Okay, easy question. I hope this is clear. This is a question on mixture and allegations. Okay. If I talk about this, if the first 4, 9, 8, 5 natural numbers are put side by side to get a big number, like 1, 2, 3, 4, so on, so on, so on, we'll get 4, 9, 8, 4, 4, 9, 8, 5. Which digit will be exactly in the middle? Okay, let's do this. So first of all, you need to count how many digits are there. If you talk about one digit numbers, there'll be 9 one digit numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you talk about two digit numbers, all of them will give two digits. How many such numbers are there? 10 to 99. How many total numbers are there from 10 to 99? Last term minus first term plus 1. That is 90. So 90 digits will be contributed by two digit numbers. What about three digit numbers? All of them will give three digits and they start from 100 to 999. So 999 minus 100 is 899 plus 1 is 900. These many digits will be contributed by these. Now you have reached four digit numbers. Now you do not have to count all four digit numbers. You're only going till 4985. So 4985 and minus your first four digit number is this plus 1. So that is 3985. Okay, 3985 plus 1 is 3986. There'll be how many numbers? 3986 numbers that we are going to count from 1000 till 4985. So can you count the total number of digits here? 9, 180, 2700, and then you'll have to calculate this, right? And this will be equal to 15944. I hope this much is clear. Since we are talking about the middle digit over here, we'll have to find out total number of digits. If you add all of these, you'll be getting 18833. So these are total number of digits. These many digits are there. So these are odd number of digits. Odd number of digits. That means you have to find out the median digit. Okay, which comes exactly in the middle. Okay. So you just have to do what? 18833, which will be the median digit, the middle digit exactly. 18833 plus 1 by 2. Yes or no? This is what you find, what you do to find out the median value in case of odd number of data, right? So that is 18834 divided by 2. So if you do this, you get 9417. You actually need the 9417th digit. So 9, 180, 189, 189 and 270 will be 2889. And you need to reach the 9417th digit. So over here, if I count all one digit numbers, two digit numbers, three digit numbers, I have already covered these many digits. I want to reach what? 9417th digit. So how many more digits do I need? 9417 minus 2889. What will this give you? This will give you 6528 digits. These many more digits I need, but now they will be starting from four digit numbers, okay? Because we have already counted all the digits till three digit numbers. This digit, we are talking about 6528 digits now, and they are going to come using four digit numbers. Okay, so we have to start from 1000 and we have to go till 6528 digits. Okay, 6528 digits. So 6528 digits, that means these are total number of digits. This is the starting number. We are going to start from 1000 and we are going to count these many digits. So we'll be going till this number because these many digits, that means this number by 4. So that is equal to how much? 4, 15, 153 to 1532. We have to go till 1532, right? This is the number we want to reach, isn't it? After 1000, I want to reach this number. So what will be the 1532th number starting with 1000? So this will be 2, okay? 2531 is going to be that 1532th number. So we have to reach the 1532th number from 1000. So that is 2531. Its last digit 1 will be the this one, okay? Exactly in the middle. So this is what we have to do here. It's a very good question. Such questions, one similar question I've seen in previous IPMATs as well. Okay. Now from this point onwards, we'll be doing tomorrow. Okay. And last 33 questions are remaining. So please like the session if you are liking the quality of questions. And we just left with one more session and tomorrow we'll finish it. I hope you're solving at your end and revising all the formulas. Thank you so much. We'll meet again.